Yes, dear students, now we are going to start revision of bonding chapter. In bonding chapter, first you can see we will start with ionic bonding. So before it, we should know what are ions. When an atom gain or lose electron, it changes into ions. For example, if we see the electronic configuration of sodium 281, it will lose its outermost electron 1 and will get the electronic configuration of nearest noble gas. So from this, we can conclude that atoms lose or gain electron to gain the electronic configuration of nearest noble gas. That is, sodium's electronic configuration becomes like neon, which has 10 electron in total to 8. So after losing one electron, it changes into Na positive. Okay. And if we see about chlorine, chlorine has electronic configuration 2, 8, 7. Total 17 proton or 17 electron. So it requires one electron. It is easier to gain one electron instead of losing 7 electron which are in outermost shell. So after gaining one electron, it changes into Cl negative. So if we see the electronic configuration of chloride ion, it is like 2, 8, 8. And if we see the electronic configuration of sodium ion, it is like 2, 8. Hope you are clear with this. So if we see ions and ionic bonding, describe the formation of positive ions known as cations and negative ions known as anions. Okay, describe the, okay, we will see it later. Ionic bonding to relevant to this, I would like to show you the specimen paper. In specimen paper, he is asking for the electronic configuration of the element. For example, calcium chloride. In calcium chloride, there are two ions. First, you have to identify which ions are present, Ca2 positive and Cl negative. If we see calcium ion, deduce the electronic configuration for each of the ions in calcium chloride. You can take the help of periodic table. If you see periodic table, in periodic table, you will find calcium with proton number 20. So if it is calcium ion, it is in second group, it will lose 2 electron. So it will get 2 positive charge, means it has lost after losing 2 electron. It will have 18 electron. So calcium ion 2, 8, and 8. Now it's become 18. In total, atom has 20 proton and 20 electron. After losing 2 electron, it become positive, Ca2 positive. And chloride ion has again 17 proton number. So it has 2, 8, 8. Actually, chlorine has 17 proton number, means it has 287 in its outer shell. After gaining one electron, it becomes 288. So Cl negative and Ca2 positive. So from this formula, we also can see that for one calcium ion, there should be 2 chloride ions. That's why it is CaCl2. Hope you are clear with the electronic configuration and the formation of positive and negative ion. Now we will move towards what is next. The next is describe the formation of positive ions known as, okay, done this, describes the giant lattice structure of ionic compound as a regular arrangement of the alternating positive and negative ions. Before, we should know what are ionic compound. Ionic compounds are formed when ions electrostatically held with each other. Ions attract each other. For example, sodium ion, chloride ion, they electrostatically attract each other. Again, I am saying it is electrostatic force of attraction between positive and negative ions, not intermolecular forces. Commonly, this is a very common mistake. Students use intermolecular forces for ionic compound. Why ionic compound has high melting point, high boiling point? Because of strong electrostatic force of attraction. They have regular arrangement. Ions in an ionic compounds are regularly arranged in a lattice structure. So I would like to show you the lattice structure of an ionic compound. Hope I have this in this. Yes, this is shown the lattice structure of, this is the lattice structure of sodium phosphate. This one. This is a simple molecular structure. Detail of this we will discuss later. There is an other example of lattice structure, which is sodium chloride. If you see, each sodium ion is bonded with 6 chloride ion. I would like to show you with the help of a diagram for NaCl, which is actually, yes. Each sodium ion is bonded with this is a cubical structure or crystal lattice structure. This small dot is showing sodium ion and a positive, and large dot is showing chloride ion, this one. So they are alternately bonded with each other. Means each sodium ion is bonded with 6 chloride ion. This is a part of your syllabus. You should know for this. The crystal lattice structure, hope so you are clear with the crystal lattice structure. There is another example of crystal lattice structure, which is this one. So ionic compound again form a crystal lattice structure with regular arrangement. There are strong electrostatic force of attraction between oppositely charged ions. It is not intermolecular forces. Remember it. Okay, we are clear with it. State that an ionic compound is a strong electrostatic attraction between oppositely charged ions. This is what I was explaining you. Describe the formation of ionic bond between ions of metallic and non-metallic elements. Yes, this is the point. Ionic bond is formed between metal and non-metal. That is, metal atom loses electron and form positive ion, and non-metal atom gain electron and form negative ion, and then they establish electrostatic force of attraction between oppositely charged ions. Okay, elements including the use of the dot and cross diagram. I will show you this dot and cross diagram on whiteboard. And also I want to see this. Describe and explain in terms of structure and bonding the properties of ionic compound, high melting point and boiling point. What is the reason again? It is not strong electrostatic, it is not strong intermolecular forces, it is strong electrostatic forces. Again, I am focusing on this. I have seen so many times students do this mistake that they use, there are strong intermolecular forces between ionic compound. No, in ionic compound, there is no concept of molecule. There are strong electrostatic force of attraction between oppositely charged ions. Good electrical conductor when aqueous or molten, and poor when solid. Yes, why? Why they are good conductor? Because in aqueous or molten form, ions are free, not electron. This is also a common mistake. Students use a word electron are free. No, electrons are free in graphite or in metals. But when we talk about compounds or ionic compound, there is a concept of ions, that ions conduct electricity in an ionic compound with the help of ions. So I would like to see if there are examples of, yes, explain in terms of structure and bonding, why compound R has a high melting point and compound S has a low melting point. Compound R is ionic compound. The appropriate answer of this is compound R is ionic compound. It has strong electrostatic force of attraction between oppositely charged ions. Whereas S is a simple covalent compound which has weak intermolecular forces. Intermolecular forces means P, H, H. Here I have drawn another S molecule. So when we talk about intermolecular forces, means forces between these molecules here, the forces which exist here. Again, covalent bond is not break. Covalent bond is also a strong bond. It requires very high temperature to break. When we say it has a low boiling point, covalent compound has low boiling point, this means they have weak intermolecular forces. You have to use word intermolecular forces. I don't know why O-level students use word van der Waals forces or give the name to the forces. There is, you don't know what type of these forces you may give wrongly. So remember, whenever you explain the forces between simple molecules or covalent molecules, covalent compound, you have to say weak intermolecular forces. Not no need to give the names of the or type of the intermolecular forces. And when we talk about the forces in ionic compound, we have to say electrostatic force of attraction between oppositely charged ions. Because of these strong electrostatic force of attraction between oppositely charged ions, they have high melting point. Again, I am repeating it. R is ionic compound with strong electrostatic force of attraction between oppositely charged ions, whereas S is a simple covalent compound which has weak intermolecular forces between its molecule. Not within the molecule, between its molecule. Hope you are very much clear about this. Again, I would like to move toward revision checklist. Hope all are you clear with this ionic. Or now next is dot and cross diagram. I will check if there is dot and cross diagram, asking of dot and cross diagram in any exam paper. Otherwise, I will help you. Draw dot and cross diagram of silicon. Now it is covalent compound. Okay. Just give me a minute. Draw dot and cross diagram for sodium chloride showing all the electronic shells. Okay. There are sometimes examiner demands. What is the demand of examiner? They ask for drawing the actually okay. Here he's asking for ionic a dot and cross diagram between the ions, and he requires all the shells, showing all the electron shells. So in first shell, sodium has 2 electron. In last shell for ion, it has 8 electron. 8 electron mean it has lost its valence electron, last shell electron, and get positive charge. There is no need to overlap the shells in case of ionic bonding. Okay. For chloride ion, there are again 2 electron in the inner shell. Okay. Second last shell has again 8 electron. This, the focus on the word dot and cross, means one ion should have dots and other ion should have cross. It is necessary. It is the demand of the exam. So dot, 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 again dot, dot. These are 7 electron, which are original electron of the fluorine atom. Now 1 electron from sodium, which is showing with cross. So we will draw the square bracket. On the square bracket, we will show the negative charge. This line is just to explain what he is asking. This one, no need of this line. So hope you are clear with this, how to draw the dot and cross diagram. I have given here one example. We can draw another example. For example, he asked about the dot and cross diagram for sodium oxide. This is a little complex structure. I would like to show you the dot and cross diagram of sodium chloride on whiteboard. Sodium oxide again, sorry. Sodium oxide. Why it is ionic compound? This is metal, this is non-metal. So sodium is in first group. One sodium atom lose one electron and become positively charged. Here, in some question, he asked, draw just outer or valence electron. After losing one electron, its second last shell become last shell, and it will have 8 electron. So here one sodium atom, highly suggested. If one element has 2 atoms and one element has 1 atom in ionic compound, draw in this way that the element which has 1 atom should be in the center. For example, this is I am showing for oxygen. Oxygen has 6 electron in total. So 2 in the, sorry, with dot, 2 in the inner shell and its own 8, 1, 2, 3, 4, 5, 6, and this is 8. From each sodium, 1 electron come. Here I would like to again draw a sodium atom in its outer shell. There are also 8 electron, and that's it has lost its 1 electron in outer shell and will get positive charge. So this is positive, and now this is negative. So with the help of these examples, we have done dot and cross diagram of sodium oxide, sodium chloride. Hope you are clear. Ionic compound form crystalline structure, and they have strong electrostatic force of attraction between oppositely charged ions. If we see a revision checklist, we have done with all these. That is, this is clear. Hope so. This is clear. State that ionic compound is a strong. Yes, this is done. Describe the formation of ionic bonds between ions of metallic. Yes, it is clear. And why they have high melting point, high boiling point, again, strong electrostatic force of attraction. That's it from ionic bonding. In next video, we will share about covalent bonding or simple molecule according to revision checklist. See you in next video.